Welcome. This is Everyday Life, and we're back with the last installment of the Chemistry 116 videos. In today's video, we will demonstrate how to properly utilize the spectrophotometer. In doing so, we will obtain absorbance values at a specified wavelength for the dilutions made. With those values, we can use the relationship between concentration and absorbance to find the concentration of an unknown dilution. We started by creating our stock solution. We then made serial dilutions from the stock solution. We then transferred an amount of the stock solutions and the dilutions into different cuvettes. We also filled a cuvette with water to be our blank. We wiped the two sides of the cuvette that will be in the beam before placing it in the spectrophotometer. We've placed the blank solution in the spectrophotometer to zero it, and we closed the lid before zeroing. The spectrophotometer needs a blank so it could be calibrated against a solution with little to no analyte of interest. Without a base absorbance value, all other absorbance readings taken after will be incorrect. After zeroing the spectrophotometer, we moved on to the scanning for the absorbance values of the stock solution and the serial dilutions. We started by placing the stock solution into the spectrophotometer and doing a scan across all wavelengths to find lambda max. Lambda max is where the absorbance is maximum at a particular wavelength. We then use the lambda max value to make a scan at a specific wavelength for the stock solutions and the dilutions. After collecting the absorbance values for the solutions, we can use the relationship between concentration and absorbance to find unknowns. Beer's law is a linear relationship between absorbance and concentration of an absorbance series. The general equation is A equals A lambda times B times C. A is the measured absorbance, A lambda is wavelength dependent absorptivity coefficient, B is the path length, and C is the analyte concentration. When working in concentration units of molarity, the equation is A equals E times B times C. E is the wavelength dependent molarity absorptivity coefficient with units of 1 over m times centimeters. And of course, at the end of every lab, we leave the lab area better looking than when we came. This concludes today's video. So if you guys did not understand the contents of this video, you need to either eat or go to bed. Peace.